Alright, this is a quick tutorial for stacks implementation using Linkedlist class. So say for example, we have here a maximum size of 5 index, or we have 5 elements or values in our linked list or our stacks. So say for example, we push 10 here. So for our time complexities ng stacks, diba, we are pertaining for 0, big O notation of 1, or constant for I may say. So here we push 10. So for our stack linked list, from our head, or the start point, it will be connected into the 10, which is the first node, which is the 10. So that is your first iteration looks like. After 10 will be connected to your now. So we are done with 10. So for 20, we will not be going to do the same thing for array. That when it comes to array, we are pushing here sa next position, diba? Amo na ang sa array naton. And it's not the same with linked list. So for linked list, we are doing the push at our head. So here, from head is 10, our node head. So the 20 will be the new head, and 10 will be the next. So the linked list will looks like head connected to 20. Then next is your 10. So then 10 will be connected to now. That is the representation of the second iteration for our 20 here. So if we will be going to push another 30, what will happen? So in our 20, since every push, we will push that in the first part. Since in linked list, the constant time is at the beginning part, at the start, at the head point. We cannot do that in the null point, because that is, if we are doing at the null point, therefore it's not called constant. It is big O notation of n, or worst complexity. So for the next iteration, for the push 30, will be happen from our head connected to our new head, 30, connected to our old linked list here, which is the 20, then our 10. So how about if we will be going to pop, we will do the pop. So what will happen is we will be going to pop the 30 here at the head point. We will not be going to pop here, because our principle that we are using in linked list is basically which is the last in first out, or the LIFO. So since we are doing here at the head point, we are inserting, or we push element here. So therefore, if we remove element or we pop element, we will also first out or remove at the head point as well, right? So what will be our linked list looks like for that? It will be the same thing here, right? So remove 30, so 20 will be the head, and 10 will be the next and connected to now. So here, if we pop 25, do you think it is feasible? Diba hindi? Because why? In doing pop function or operation, we don't have parameters. It is only applicable to pushing elements. So therefore, your answer for that iteration is only true or false, or error. That is your only answer for this pop. Okay, next, since our operation here, we pop the 30, so this is our answer for this here already. So when we push 40, we will be going to put this as a new head, right? Node head. So our linked list will looks like this. From 40, then connected to 20, and connected to your 10, and 10 is connected into your null point, right? So when we establish or push 50, so therefore 50 will be the new head connected to 40, and 50 will be the new head. So kindly remember that our maximum size is only 5 elements. So we need to count 1, 2, 3, 4. So it's still 4. So our linked list is not yet full. This is not head already here, because we put 50 here, we push 50. So therefore 50 the new head, and connected to our old elements. So when we push 60, so therefore 60 will become the new head connected to the 50 or the old linked list you have, and this will become the new head. So we are done with 60. So here, look here, we do have 5 elements already. Then here we are pushing another element, which is 70. So if we will be going to push 70, that is not feasible already. Why? Because we establish or we implement here or declare that we can only store 5 maximum size in our certain linked list, right? For our stacks. So therefore we cannot add the 70. What will be the answer for that? Our stacks overflow, or will become stacks overflow or error, right? So go back to your linked list na lang. And then when we establish the peak element, peak is what we called peak or the top element or operation. So in dealing with peak or top, we are accessing the first head, the first or the top element. We cannot say that 10 is the top because that is the bottom if we are doing linked list, this stacks operation. 10, 20, 40, 50, 60. So top ang 60. So since LIFO or last in first out, therefore dirigid ang top. Okay? So if we are establishing here is full operation, does our linked list is already full? So we have 5 elements maximum size, 1, 2, 3, 4, 5. Therefore, is full operation is true. Okay? And if we are also finding is empty operation, therefore it is false because we have 5 elements in our linked list. So that is the stacks implementation using linked list works. It's not just to correct that we are not the same process with arrays that we are pushing at the last element. Amo na ang sa linked list, sa array. But for linked list, we are pushing at the head point because we cannot do in the last point since we are not doing linked list only. This is doing with stacks implementation using linked list. If you are doing only linked list, specifically with insertion to at the end part, you can definitely insert at that tail point. But then on for doing stacks implementation using linked list, therefore you need to do this like this. Since head point or the start point, dira ta ga-insert, kag dira ta ga-access sang constant point. Okay? So for question, just message me in our MS team or through our group messenger chat. And that's all for this presentation. Thank you, class.